we're going to be looking at tangent functions. So with tangent functions, they're a little different from the cosine and sine functions we did earlier. So just a couple notes here. There's no amplitude with these guys, and there's no vertical displacements. All right, there's only going to be periods, and which we refer to K, and there's going to be a phase shift. And the period is not going to be 2 pi over b like we did with sine and cosine. It's going to be pi over k. Okay, so let's have a look at this picture I have below of a tan function. Okay, a couple things you got to understand. Number one, tan is really the ratio of sine of x over cosine of x. All right, so by understanding the sine and cosine wave, we can get a good picture of what the tan function will look like. So I'm going to draw in the sine function. I'll make sine red. Okay, so remember back we have 0 where we start in the middle, and we're using the amplitude of 1, and then we go back to the middle, back to the bottom, and then back up. So there is a sine function. All right, now let's look at the cosine function, which is in blue. Remember, the cosine positive starts at the top, and it goes down to the middle, down to the bottom, back to the middle, and up to the top. So it looks like that. So how does this sine wave come about? Well, if we look at the values of sine, when sine is 0, so if I put a 0 on the numerator and have some number there, I know the answer is going to be 0. So I know when sine is 0, so these are the red ones, so right there, and right there, and right there, those are going to be my tangent zeros. Now, when I look at the cosine, and if I have a 0 on the bottom for cosine and some number on top, I know this is undefined because you can't divide by 0. So that's why when you see a 0 on the cosine wave there and there, those two spots, you notice there's an asymptote drawn. Okay? And how these lines come about, these sort of called squiggle sneaky lines, is that if you look at the functions, so I'm going to look at the cosine, the blue one, as this blue one, I'm just going to be drawing here dot, 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 as this blue one is coming closer and closer to 0, see this yellow line coming down, a number divided by a very small number, I'll just put 0.001, it's going to be a very large number, and we say it's infinity. That's why you see this guy shooting up. It's going up to infinity. And the same thing if it's going the opposite direction. This is coming up, so it's going down. All right, so that's how you get the graph. Now, a couple features. The period is between the asymptotes, or you can say the period is between the dots. So you go dot to dot or asymptote to asymptote. Now, how do we get the asymptote? Well, the asymptote is half of the dot to dot. So this x-intercept and this x-intercept. So if I go halfway, right there, that's what becomes the asymptote. So remember, it's halfway between the dots. All right, so let's look at a diagram here, and just draw one out. Okay, so the first thing is, oops, keep getting the wrong thing here. We are going to graph this function right here. Okay, so the first thing is, remember there's no A, so there's no A, there's a B, there's a C, and there's no D. So the B is what's next to the X, so it's 2. Now the period is pi over that. And the phase shift, because there's no bracket here, it's 0. So let's get a sketch. So I'm going to make the X and Y axis. There's Y. There's X. Okay, now once we have these features here, the period is 2, we're going to, and we got the phase shift is 0. This is the first thing you're going to plot, phase shift. Well, 0 is right there, so we know we're starting right at origin. Now we're going to go do this next, second thing. So I'm just going to count by 4. So 1, 2, 3, 4, and I'm going to call that pi over 2. Then 1, 2, 3, 4, I'll call that pi. 1, 2, 3, 4, I'll call that 3 pi over 2. Then 1, 2, 3, 4, I'll call that 2 pi, and I'll just go back 1, 2, 3, 4. So negative pi over 2. Okay, so now I got it labeled. We're going to draw. So the first thing is, I know the first dot is at 0, so right there. Now the next one is going to be a period away, so pi over 2. The next one is going to be another pi over 2, another pi over 2, another pi over 2. So now I got the dots. Now the asymptote. Remember, the asymptote is halfway, so halfway between these dots. Well, if I look at this, I know that halfway is right there, and I know half of pi over 2 is pi over 4. So it's good to label the closest one to the x-axis, so I did that. So I know there's going to be an asymptote right through there, and the same thing at all these halfway points. So I'm going to draw those in. And one over here. Okay, now I have it set up. Now I can draw what I call the snakes. Remember, it's going to hug the asymptote, and it curves, and then it hugs there. Put your arrows on. Hugs, curves, and goes up. Hugs, curves, and goes up. And so on. So you get the idea. All right. Now, once I have the graph, I can do the domain. So the domain right here, I'll just put down here. The domain, it's going to be all numbers. So x, e, r, except x cannot equal the asymptotes. Okay? So you can't just be general. You have to tell me what the asymptotes are. So you say x cannot equal. You pick the closest one. That's why I labeled it. Pi over 4. And it happens every nth away. So it's every, so you add the period. So the period away is pi over 2 and then n, n-e-i. Okay, so that just represents every period away. Now, the range. Okay, I'll do the range. The range is a little easier because it's going up forever and down forever. So that's just YER. All right. Now these values, the value of pi over 8, well, you're just injecting that into the x right here. You type it into your calculator and you should get a value of 1. And if you punch this one in, hopefully you got an error, which is undefined. And why? Because it's an asymptote.